Piping systems can be created in two ways. One way is to simply add pipe to connect the water side components, and they will automatically be added to a piping system. The other way is to select the component and manually add them to a system. Then you can have Revit generate and lay out the piping. However, with several components in a system, it's difficult to get the results you are looking for. In this model, two piping systems have already been created: condenser water supply and condenser water return. Let's take a look at how Revit generates piping layouts. I'll select the cooling tower. When I do, a piping system's contextual ribbon appears next to the mechanical equipment contextual ribbon. I'll switch to the piping system's contextual ribbon. Now, a dashed line appears around all the components in the piping system. A dashed line also appears around each individual component. In the contextual ribbon, you can also see the name of the piping system in the system selector. I'll switch back to the Modify Mechanical Equipment contextual ribbon. Pay attention to the tools in the Layout panel. Here, we have Generate Layout, Generate Placeholder, and Connect Into. The Generate Layout tool provides different layout solutions to add selected equipment and components to a piping system. The Generate Placeholder tool is pretty much the same, only it uses pipe placeholders besides actual pipe elements. Lastly, Connect Into will create a physical connection between a selected component and a pipe. I'll click Generate Layout. Revit displays the Select a System dialog. Since the cooling tower belongs to two piping systems, we can select which system we want to generate a layout for. I will select the Condenser Water Return System, CWR, and then click OK. When I do, Revit goes into Generate Layout mode. Within a few seconds, several solutions have been provided. In the Options bar, you can expand the Solution Type drop-down to choose one of the solution types: network, perimeter, or intersections. There are various layouts for each type. For piping systems, perimeter or intersection is typically the best. For example, I'll choose perimeter. Notice that for this solution type, there are 5 layouts. We are currently viewing one of 5. You can use the Next Solution and Previous Solution buttons to view the various layouts. Let's try solution 4 of 5. Also, if you have not specified the pipe conversion settings in the Mechanical Settings dialog, you can do so now by clicking Settings. This opens the Pipe Conversion Settings dialog. As you can see, these settings are for the hydronic return system type. You can control all the settings in the Mechanical Settings dialog. I'll ensure that the pipe type is set to carbon steel for both the main and branch settings. Then I'll click OK to close the dialog. If you do not see a solution that you like, you can choose Edit Layout in the contextual ribbon. Then you can select and move any of the main and branch pipe route paths. You can also select Remove From System to remove any of the components from the system layout, or Add to System to add a component back into the system. Once you are satisfied with the layout solution, you can click Finish Layout and Revit will generate the layout. Once the layout is generated, several warnings appear. Since there are multiple components in this system with pipe connectors at varying elevations, Revit has trouble generating an accurate layout. However, you may wish to start with this and modify the layout that Revit has generated. I'll click anywhere to dismiss the warning and then click Undo until the pipe is removed. Sometimes with piping systems, it's easiest to manually lay out the system. For example, I'll zoom into the cooling tower and then select it. With the component selected, pay attention to the icons at each connection. You can see an icon indicating the connector type as well as the size and additional information. I will click on the top hydronic icon. When I do, a Select Connector dialog appears. This is because there are two connectors at the same location in Plan View, but they are at different elevations. I will select the hydronic supply connector and then click OK. Once I do, the pipe tool is active and the starting point of the pipe segment has already been placed at the connector I just selected. Now I can create the main pipe segments. I'll move the cursor to the left and click to place a horizontal segment. Next, I'll change the offset in the options bar to 10 feet 6 inches, or 3,200 millimeters in the metric file. Then I'll move the cursor to the left past grid line 2 and click to place another segment. Now I'll move the cursor down past grid line H, click to place another pipe segment, and finally move the cursor to the right and create a final main pipe segment. I'll click Modify to end the command. As you can see, I used the same pipe diameter to create the entire main supply pipe, and I will size the pipe after the branches are connected. However, you could create several more pipe segments along the path and change the size as you go. The next step to laying out this piping system is to connect each water source heat pump to the main pipe. I'll zoom out and pan up to the north side of the building. I'll start with the first water source heat pump along the path of the pipe. When I select this water source heat pump, pay attention to the connector icons. Once again, I can see a hydronic icon, and when I click this icon, the Select Connector dialog appears. This is because the hydronic supply and return connectors are at the same location on the equipment, just at different elevations. Since we are laying out the condenser water supply system, I will select the hydronic supply connector and click OK. Now I am creating a pipe segment from that connector. I will click to create a horizontal segment and then click on the main pipe to place a vertical segment. When I do, realize that Revit has connected the vertical segment to the main pipe segment by placing the appropriate fittings as well as another pipe segment perpendicular to the work plane. This is because Automatically Connect is selected in the Placement Tools panel of the contextual ribbon. The pipe tool is still active, so I'll click Modify to end the command. You can also use the Connect Into tool to do the exact same thing we just did here. For example, I'll select the next water source heat pump. Then I'll select Connect Into in the contextual ribbon. Revit displays the Select Connector dialog. Once again, I'll select the hydronic supply connectors and click OK. Now I must select the pipe to connect into, so I will select the main pipe. When I do, pipe segments and fittings are created to connect the hydronic supply connector on the water source heat pump to the main pipe. At this point, I can select the vertical segment and move it as necessary. The other segments will remain connected to the vertical segment when it is moved. I'll switch to the 3D piping plan view to take a look at the results so far.